Hi friends and welcome to Geeks for Geeks. Today we are going to learn how to find the minimum number of bracket reversals needed to make an expression balanced using stack. So here's the problem. Given an expression with only opening and closing brackets, the initial expression may or may not be balanced. We have to find the minimum number of bracket reversals to make the expression balanced. Let's take for example this expression. This expression will give the output 2. Since we need to change this opening to closing bracket and this closing to opening bracket so that the expression becomes balanced. The balanced expression becomes this. Let's take another example. For this expression, we can never get a balanced expression no matter how many reversals we make because it contains odd number of elements. Any string with odd number of elements can never be balanced. Let's take another example. In this example, we can see that this part is already balanced. So we just have to balance this part. If we change this, that means we reverse this bracket, we get a balanced expression. So the output is 1. A simple solution to this problem is to consider every bracket and recursively count the number of reversals by taking both the cases. First, by keeping the bracket as it is, and second, by reversing the bracket. But this is not an efficient way of doing this problem since the time complexity for this problem, for this solution is O of 2 raised to power n, which is huge. Let's look at an efficient solution now. The idea is to first remove all the balanced part of the expression. After removing the balanced part, we always end up with the expression of this form. That is, first we get all the closing brackets and then the opening brackets. Now how to do this? So first we create an auxiliary stack S and iterate through the string. When we get a closing bracket and the top is not an opening bracket, we push that element into the stack. If we get a closing bracket and the top is a opening bracket, we pop one element from the stack. Else, when the element is an opening bracket, we push it into the stack. Now, how many minimum reversals are required to make this expression balanced? Let m be the number of closing brackets and n be the number of opening brackets. Then the ceiling of m by 2 plus ceiling of n by 2 is the total number of reversals. So why the ceiling of m by 2 plus ceiling of n by 2 is our solution? So let's look at that. So we are reversing m by 2 ceiling of m by 2 number of closing brackets and so that it matches with ceiling of m by 2 number of opening brackets, and we are reversing ceiling of n by 2 number of opening brackets so that it matches with ceiling of n by 2 number of closing brackets. And we know that ceiling of m by 2 plus ceiling of n by 2 is equal to length. So essentially we have made the entire string balanced by doing this. Let's look at an example now. We assume our string to be this. So first we have to remove all the balanced part from the string, which is the bold part. So let's work our algorithm on this. First step, we create a stack S and then we iterate through the string. We see that at I equal to 0, we have a closing bracket and the top of stack is not an opening bracket. So we push this element into our stack. We see that at I equal to 1, we have an opening bracket. So we push it into our stack. At I equal to 2, we again have an opening bracket. So we push this 2 into our stack. Now our stack becomes this. At I equal to 3, we can see that we have a closing bracket and the top of stack is the opening bracket. So we pop one element from the stack. Now our stack becomes this. At I equal to 4, we have a closing bracket and top of the stack is still a opening bracket. So we pop another element from the stack. Now our stack just has a single closing bracket at the top. We can see that at I equal to 5, 6 and 7, we have opening brackets. So we push them into our stack. Our stack now becomes this. So after removing the balanced part, our stack becomes this. and the value of m is 3, that is the number of closing brackets, and the value of n is 1, which is number of opening brackets. So ceiling of m by 2 plus ceiling of n by 2 is 2 plus 1, which is 3. So the output is 3. Now let's look at the implementation of this problem in C++. So first we calculate the length of the string. If the length is odd, we return -1. That means the string cannot be balanced, because in an odd numbered string we cannot form pairs. If the length is even, we iterate through the string. If we get a closing bracket, we check whether the top is an opening bracket or not. If the top is an opening bracket, we pop one element from the stack, else we push it into our stack. If we get an opening bracket, we push it into the stack. Here we are calculating the length of the reduced stack, and then we are calculating the number of closing brackets, and we return the result, which is ceiling of m by 2 plus ceiling of n by 2. The time complexity for this solution is O of n, since we are traversing the string only once, and the space complexity is also O of n, since we are creating another stack. This brings us to the end of this tutorial. Thank you for watching. Please leave us your likes and comments in the comment section.